Today's lesson is solving radical equations. The first thing we need to look at when we're looking at radical equations is what a radical equation is. It is an equation with a radical that has variables in the radicand. Keep in mind that the radicand is the number or the variables that are inside the radical sign. That is the radicand. Now the next thing that we have to look at is how to solve radical equations. The first step you want to do is to isolate the radical on one side of the equation. That means you want to get it all by itself. The second step is you have to raise each side of the equation to the same power to eliminate the radical and obtain a linear, quadratic, cubic, or any other kind of polynomial equation. And the third step is to solve the polynomial equation using techniques that you have previously learned. What that means is once you raise the power, then you might have to add, you might have to subtract, you might have to distribute, you might have to use the FOIL method. So there are numerous things that you might have to do in the process of solving the polynomial equation. The first one we want to look at is to solve a radical. We're looking at the cube root of 5 minus 11x equals 3. So again, remember back to our steps. The first thing we need to do is isolate, but I think it's pretty well isolated. So the second step was to raise both sides to the same power. So what will cancel out the cube root is raising the cube root to the third power, which means we have to raise the other side to the same power, which is cube. Now, this cube root is canceled by cube, so I have 5 minus 11x equals 3 cubed is 3 times 3, which is 9, times 3 is 27. Now, we want to get our x by itself. The first thing to do is to move my 5. Right now it's a positive 5, so what I have to do is I have to subtract 5. So I have a negative 11x equals 22. Now, to get rid of the negative 11 that's attached to our x, we have to divide by a negative 11. Again, we have to do it to both sides. So x equals a negative 2. Once we do this, though, we want to go ahead and check to make sure that's the right answer. And how we do that is we say cube root of 5 minus 11 times a negative 2, is that equal to 3? The cube root, this is my check. The cube root of 5, and then a negative 11 times a negative 2 is plus 22. Is that equal to 3? The cube root, 5 plus 22 gives me 27. Again, is it equal to 3? The cube root of 27, 3 times 3 is 9, times 3 is 27. So yes, we can say that 3 is equal to 3. And so therefore, negative 2 is your answer to the cube root of 5 minus 11x equals 3. The next concept we want to look at is solving an equation with a rational exponent. So what we're looking at is x minus 1 to the 2/3 power plus 2 equals 6. So again, the first thing we want to do is isolate anything with a power, all right, which is the exponent. So I'm going to go ahead and in order to do that, I need to move my 2. Right now it's a positive 2, so I'm going to subtract 2. So now I have x minus 1 to the 2/3 equals 4. The next thing I want to do is get rid of my power, which is the 2/3. Now the way to do this, and I'm going to set it up, I'm going to use brackets. I'm going to say x minus 1 to the 2/3 power in my bracket, Now, in order to change, if you think about fractions, when we're moving fractions from one side of an equal sign to another, what you do is you flip it upside down, or you use the reciprocal of it. So I'm going to go ahead and say to the 3/2 power equals 4 to the 3/2 power. Now, as you can see, 2/3 and times 3/2 equals 6/6, which is to the first power, and that's what we're wanting. So we can go ahead and mark those out. Now we have x. Oh, I don't need the parentheses anymore. I can say x minus 1 equals, what this stands for, and I'm going to write it over here to the side, this is the square root of 4 cubed. The square root of 4 is 2, and 2 cubed should give us 8. Alright? So I'm going to go ahead and write 8 there. And again, that's where I get this. I have the square root of 4 is 2 cubed, and then 2 cubed is 8. So I'm going to go ahead and write 8 right there. The last thing I want to do is move my negative 1, so that becomes a positive 1, plus 1, so x equals 9. So again, if I want to, I can check it. I want to check my work. And so I can say 9 minus 1 to the 2/3 power plus 2 equals 6. 9 minus 1 gives me 8 to the 2/3 power plus 2 equals 6. Again, I can rewrite that, and I can say the cube root of 8 squared plus 2 equals 6. The cube root of 8, remember 2 times 2 is 4 times 2 is 8. So that means I can say 2 squared plus 2 equals 6. 2 squared is 4 plus 2 equals 6. So 6 does equal 6. So therefore x is a correct solution for x minus 1 to the 2/3 plus 2 equaling 6. Now we want to look at solving an equation with extraneous solutions. An extraneous solution is an answer that we come up with when we solve, but when we put it back into the equation, it does not make the equation true. And so that is why it's important when you're working with radical equations to check your work, because there will be times that you have extraneous solutions. So we're looking at x minus 2 equals the square root of x plus 10. We can see that the radical is already by itself, so we need to get rid of the radical. And remember that it said to do that, we have to raise it to that power. Anytime you see just a radical sign, it means squared. So I'm going to go ahead and put my 2 there. Now I can rewrite this and say x minus 2 squared equals the square root of x plus 10 squared. Now remember, square root cancels out squared. So I can say x minus 2 squared equals x plus 10. What we have to do now is remember, because this whole parentheses is squared, we have to rewrite x minus 2 times x minus 2 equals x plus 10, and we have to FOIL. So x times x is x squared. X times a negative 2 is a negative 2x. A negative 2 times x is a negative 2x. And a negative 2 times a negative 2 is a positive 4. Again, it equals x plus 10. We want to combine like terms. And so I'm going to say x squared. A negative 2x plus a negative 2x is a negative 4x plus 4 equals x plus 10. Now what I want to do is I want to move everything over to one side of the equal sign and set this up equal to 0. And so in order to do that, I have to subtract an x and I have to subtract a 10. So I'm going to subtract an x and I'm going to subtract a 10 on this side. And that leaves me x squared minus 5x minus 6 equals 0. What you do at this point is you have to factor. The factors of 6 are 1 times 6, or we have 2 times 3. Because I have a negative by my 6 and a negative by my middle number, which is my 5, I know that my highest factor has to keep a negative sign. And so I have to make it equal 5, a negative 5. So I can say, well, if I do a negative 3 plus 2, that doesn't give me a negative 5. But if I do a negative 6 plus 1, it does give me a negative 5. And so I can rewrite this as x minus 6 times x plus 1. From here, we're going to solve each one. X minus 6 equals 0, and x plus 1 equals 0. X equals, we have to add 6 and add 6 to get x by itself, so x can equal 6, and we have to subtract 1 and subtract 1, or x can equal a negative 1. Now we have to choose to put both of these back into the equation to see if they are both correct statements. So again, I'm going to check my work. I'm going to check and I'm going to check. The first one is 6 minus 2 is equal to the square root of 6 plus 10. So I have 6 minus 2, which gives me 4, equals the square root of 6 plus 10. 4 equals the square root of 6 plus 10 gives me 16. And so the square root of 16 does give me 4. And so that is a true statement. Now, we need to check again for the negative 1. And so I can say a negative 1 minus 2, is that equal to the square root of a negative 1 plus 10? A negative 1 plus a negative 2 is a negative 3. Is that equal to the square root of a negative 1 plus 10? A negative 3 equals to the square root. Negative 1 plus 10 is a positive 9. So a negative 3 does not equal a positive 3. So therefore, your negative 1 would be extraneous. And so your 6 is your correct answer. The last concept we want to look at today is solving an equation with two radicals. What we have to do on this, because there are radicals on both sides, is we have to go ahead and use the power, and that will get rid of both of the radicals. Again, if it does not have a number in the check mark part of the radical symbol, that lets us know squared. And so I'm going to go ahead and put that. You have to know that to know which power to use. And so what I'm going to do is I'm going to go ahead and I'm going to say the square root of x plus 1 squared equals the square root of 3x minus 1 squared. Now, over here, that lets us know square root cancels out squared, so I have x plus 1. However, we can't do that on this one because we have something that's not under the radical. And so what we have to do is we have to FOIL. So I'm going to go ahead and say the square root of 3x minus 1 times the square root of 3x minus 1. Now you can FOIL this, and remember we have square root of 3x times square root of 3x gives us just 3x. And then we have square root of 3x times a negative 1 is a minus square root of 3x. And then the square root, a negative 1 times the square root of 3x gives us another negative square root of 3x. And then we have a negative 1 times a negative 1 gives us a positive 1. What we have now on this side is we have 3x minus 2 square root 3x plus 1. And again, this is my x plus 1 equals. What I want to do is move everything that's not involved with my radical to the other side of the equal sign. So I'm going to go ahead and say minus 3x and minus 1. So I'm going to say minus 3x minus 1. So that gives me a negative 2x equals a negative 2 square root 3x. Now, at this point, we can divide by my negative 2 because that's still not part of the radical. So I can divide by a negative 2 and divide by a negative 2. And so that gives me x is equal to the square root of 3x. But we still have to get rid of the radical. And so now, I'm going to say x squared equals the squared root of 3x squared. Or again, square root cancels out squared. So I have x squared equals 3x. Now, in order to solve from here, we have to move everything to one side. And so I'm going to say x squared, I'm going to subtract 3x. X squared minus 3x, and I'm going to set it up equal to 0. What does x squared and x have in common? Negative 3x. They have x in common. So I can say x times what's left is an x minus 3 equals 0. And so you set each part up equal to 0. X equals 0, and then x minus 3 equals 0. This one has already been solved, but we have to solve this one. I want to add 3 and add 3, so x equals 3. Now, again, I've solved. I got x equals 0 and x equals 3. We need to go ahead and put that back in to check our work. And so I'm going to go ahead and say the square root of 0 plus 1 equal to the square root of 3 times 0 minus 1. So I have the square root of 1 equals the square root of 0 minus 1. The square root of 1 is 1, but that does not equal a negative 1. So therefore, I can put the line through it because it does not equal. So we have to try our 3. The square root of 3 plus 1 equal to the square root of 3 times 3 plus 1, minus 1. So the square root of 4, is that equal to the square root of 9 minus 1? The square root of 4 gives us 2. The square root of 9 gives us 3 minus 1. So 2 does equal 2. So therefore, your answer to this equation is going to be x equals 3.